Hello everyone, welcome to Olsen Cafe. In today's lesson, I will show you the strategy I use to help students in tackling this complex question in calculus, which many students struggle. At the end of the lesson, I will summarize for you the three key takeaways to help you master the art of differentiate, then integrate. So let's take a look at this question here, which is a very common one in GCE examination. We can easily solve this once you are able to grasp the fundamentals. So what we see here is the product of two functions, which is x squared and ln 3x. So therefore, we are going to apply product rule. Yeah, so using product rule here to help visualize, I have color coded it. So I'm going to use purple, right, to represent the function u, and ln 3x green, all right, which is a v. Yeah, before I move on to apply the formula, so what we will want to take a look is how can we differentiate the function ln 3x. So over here, to differentiate this, I will get 1 over 3x, and then I differentiate the function 3x again, which is 3. So by putting these together, all right, I will have u dv dx and then plus v du dx. Yeah, so once I have this, I just simply, all right, simplify the functions, and I will be able to get x plus 2x ln 3x. So now we are ready to move on to part 2 of the questions. So over here, this is where students find it very difficult to manage simply because of this word hence. Yeah, so hence simply means that we will need to make use of the result that we have gotten from the earlier part. Yeah, so before we move on, it is important to take note that integration is the reverse of the differentiation. So before we can actually start to find the integral of x ln 3x, yeah, so what we will want to do is we want to make use of this result here. So this result, as in, since I differentiate x squared ln 3x, that gives us x plus 2x ln 3x, which means if I integrate the right hand side, all right, I will be able to get the left hand expression, right, the original expression x squared ln 3x. So this is the most important part of the question here, all right, the working. So you must start it right. Yeah, so start from where you already have. Now, so at this point, I will also want to highlight, many students forget to add a constant c. So never forget that, because when you differentiate x squared ln 3x, even with a constant, right? Because when we differentiate a constant, you get the zero term. Yeah, so that will give you the left-hand expression as well. So do bear in mind to remember to add a constant c. So you can use any other letter, it doesn't matter. And over here, we are going to deal with quite a number of constants. So I'm going to use a different notation to represent different constant. So just to bear that in mind. Now, so what we want to also take a look at this point is that what we wanted to find is integral of x ln 3x. So if we make an observation, right, we will see, all right, we will see a relationship between x ln 3x and this expression here. So which means now my goal is to make this expression 2x ln 3x as the subject. So to do that, I will have to split the integral. Right? So when I split the integral, I will be able to get integral x plus integral of 2x ln 3x. So by doing this, my right hand side is still the same. So what we want is, because the goal that I want is to have 2x ln 3x as the subject, right? So what I want now is I'm going to move integral of x to the right hand side. Yeah, so to do this, I will integrate x, which gives us half x squared. So to do that, I'm able to get this new expression. So if you take a look, right, you made an observation, right? You take a look, the constant now changed to C2 instead of C1, because I'm dealing with a new constant. Yeah, because when I have a new integral x, when I integrate this, I'll have another constant. So combine this, I'm using C2 to represent the new constant. Now, once I have it here, we are going to further simplify. So I know that there is an extra constant 2 compared to what I'm supposed to find. So what I'm going to do is I'm going to take out the constant 2. Yeah, so to do this, my right hand side remain the same. So for me to get integral x ln 3x, what I need to do is I will need to bring the 2 to the right hand side, which means I will need to multiply half to both sides to get rid of the constant 2. So to do this, my left hand side is already the integral that I'm supposed to find, and then I simplify the right hand expression. I will be able to get half x squared ln 3x and then minus 1/4 x squared plus c. So again, I would like all of you to pay attention to the constant, right? Instead of using C2, right now I have my final constant. So why? Because C2 and I divided by 2 again, I get a new constant. So very often students tend to write the answer here, the constant, as C2 over 2. No, so not necessary, right? All we need to do is we just write down a letter to represent the overall constant. All right, so this is what we need to do. Now, so at this point, I would just want to very quickly, all right, go through 3 key points, all right, in order for you to solve this particular question. So what is important for point number 1 to take note is you must start it right. So what do I mean by start it right? Remember earlier at this point here, I mentioned that, right, this is the most critical part of your problems. All right, so that means before we can even find the integral of x ln 3x, you must start it right. So always start off from what you have already found. Never start from what the question wants you to find, but instead start from what you have. So because you are using integration as the reverse of differentiation, right? So that means when I integrate the right hand side, the expression, I should get back the original expression. Yeah, so must start it right. Yeah, so after which, and then when you simplify, is a lot easier. Now the second point that I want to take note is the presentation, and this is a part whereby many students make presentation error. So what do I mean by that? Now, so remember that we have integral and always come together with the dx. So this dx simply means that I am going to integrate this expression here with respect to x. Yeah, so this symbol integral and the dx must come together as a pair. Yeah, so whenever you have an integral sign, it must come together with the dx. So students often miss out on writing the dx. So if you can see, right, integral come with the dx, and then when I write the integral symbol, it must come with the dx. Yeah, so I hope you get the idea from there. Yeah, so the last part that I want to highlight would be, right, the dealing with the constant c. So these are the 3 key points, right, for all of you to take note if you want to be successful in questions like this. Right, these are the 3 pointers whereby very often in the examination, right, we see students always struggle in this area. So do take note of these 3 key points. So I hope this lesson helped you to understand this part of the calculus, all right, better. So this is how you handle differentiate then integrate question. So with this, I hope you find this video useful. All right, thanks for watching, and I will see you in the next video. All right, bye.